Hey there, how you doing? Good? Okay. So we are simplifying, and this thing is called a complex fraction. Why is it called a complex fraction? Because technically it's a fraction. I have a numerator and a denominator, and I have fractions within the numerator and the denominator, which was why they call it complex. Now, there's actually a couple different methods you can use to simplify this. All right? It just depends upon what you see, and I'm just going to leave it at that. It depends upon what you see. So here's the deal. What I know is this. I have a numerator, and in the numerator, I have an addition of two fractions. And in the denominator, I have addition of two fractions. So here's what I'm going to do. I am going to kind of do two separate problems for the time being. I am going to take my numerator and I am going to add these two fractions together. Well, in order to add them together, you need a common denominator, which would be a times b, which means fraction number 1 gets multiplied by the variable b in the numerator and denominator, and fraction number 2 by a, which means we end up with 2b plus a over a times b. That's our numerator. Okay with that? Now the denominator has an addition of two fractions as well. I have 1 over a plus 2 over b, and I want to add these together. Common denominator, which, good, multiply the first one by b and the second fraction by a, which would give me b plus 2a, I hear you, just changing pens, b plus 2a over a times b. Excellent. Good job. And now I'm going to come back over here, and I'm going to rewrite this as 2b plus a over ab in the numerator. Help me out a second before I continue. What does that line mean that separated numerator and denominator? Good, division. So do you mind if I write this technically as a division problem? Because then I kind of get rid of this complex fraction look. And so I'm taking the numerator and I'm dividing it by the denominator. Are you okay with that? Good. I'm grateful you remembered that that line separating the numerator and denominator meant division. Because as soon as I write it this way, now my brain is like, oh, I'm just dividing fractions. So how do I divide fractions? You multiply by the reciprocal of fraction number 2. Good. So this is 2b plus a over ab times reciprocate fraction number 2, ab over b plus 2a. Aha! Do you see what I see? Yeah, you can cancel the ab's, can't you? Can you cancel the 2b plus a with this? Nope. So we end up with 2b plus a over, and I'll write this in alphabetical order, 2a plus b. So be it. I can't cancel anything because the addition won't let me, and we're done. So recap. Notice what I did. I noticed in the numerator was an addition of two fractions, so I added them. I noticed the denominator was an addition of two fractions, so I added them. And then I brought the two back together, and I took the numerator and divided by the denominator, which triggered in my brain to make it a multiplication problem and to reciprocate fraction 2. And gratefully, in this case, I could cancel. Not always, but gratefully I could in this case. Cool? Okay, so I have some examples coming your way. Work on them before you find my answer key video. Cool? Catch you on the flip side.